shake it up.
Okay, let's go over our answers for the warm-up here. Okay, let's talk about number one. What form is number one in? Keenan? I didn't hear what you said. Vertex, perfect. And from there, what can you get, Tyler? Perfect, and that's like the minimum or the maximum, right? What else can we tell from vertex form here about this one? Sophie? What is it? And what does that tell us? If A is -4, the shape goes down. So it's like an N. It opens down. So that vertex will be a maximum point. And, Keenan?
I was just going to ask the vertex. Is it negative or positive?
Negative. Anything that is inside the parentheses is opposite of what you would think it is. Stuff outside is true to form. And then the other thing, we can tell the axis of symmetry, right? What's the axis of symmetry for one? X equals -2, perfect. And the A being -4 means it's going to be a lot narrower. Good. Okay, how about number two? What form is that in? That's in standard, good page. What can we tell? The side of the room's really quiet. What can we tell from standard form? Listen to page. Okay, and what does that happen to be for this one? The 10. So it would be 0, 10 as a point. And there's one more thing we can tell. Not X, that's factored form. A, and what is A in this case? 1/2. So that means, again, it's going to open up. And now is it going to be narrower or wider? Wider. So anything that's between 0 and 1 is going to be wider. Okay, good. Any questions on those? Okay, let's take a look at number 3 then. What in the world do I mean when I say greatest common factor? What am I looking for? Sophie?
The smallest number that they can all go with.
All be divided by. Yes. So you're looking for actually the biggest number that can be divided into each of them.
But don't you want to
But it has to be evenly divided. So what number can be divided evenly into 2, 4, and 6?
12?
No.
2.
2. You're thinking multiples of them. You're thinking the greatest common multiple. You got to think about what can be divided evenly. So for the first one, the greatest common factor turns out to be 2 because each of those can be divided by 2. And then what else do they have in common? Carissa? X. So the greatest common factor is X. And then do you remember in algebra, you took that greatest common factor and it's kind of the opposite of distributive property. You pulled that out from each of the 3 terms by dividing it. And what was left over went in parentheses. So if I have 2x to the 4th and I divide it by 2x, what do I have left? 2 divided by 2 cancels out, right? That's 1. But it's x to the, because third cubed, yes. Think about what do I need to multiply 2x by to get 2x to the 4th? What do I need to multiply -4x squared, or 2x by to get -4x squared? That would be 2, because -4 divided by 2 is 2. There you go. And then what do I need to multiply 2x by to get 6x? There you go. You just went back to freshman year, probably April, May, and did some factoring, which we're going to do more of today. For number 4, what is the greatest common factor? What number can they each be divided by evenly? Just 1, right? And then do they all have an x in common? So it would be x. We usually don't write 1 as a coefficient. And then what would I have in parentheses? X times what would give me 3x cubed? 3x squared, good. Divide that by x. X times what would give me 5x squared? And 2x times, or x times what would give me 2x? Not x, because we pulled that out. Nice thing about these is you can use the distributive property to double check. You can literally take the 2x and distribute it into everything, and you should get your original problem. So if I took 2x and multiplied it times 2x cubed, I would get 2x to the fourth. If I multiplied it times negative 2x, that would be negative 4x squared. And if I multiplied it times 3, that would be plus 6x. So it works out that the distributive property and my original problem work out. Okay? Does that kind of refresh some memories a little bit? I don't expect you to be experts right now, but I just wanted to put that in there so that you're aware we need to know how to do that. Okay, then let's take a look at that homework assignment. Homework assignment. Did anybody have any questions on anything from the homework? That's 2.1 worksheet. Let me get my worksheet out. Any questions on the front or back? Good with the 3 forms? Now, some people have already asked me, and they said, Mrs. Hurley, are you going to give us those 3 forms for the summative or for the formative? The answer is no. I'm not going to give you those forms. But remember, if you have all of your homework turned in for this chapter, by the time the summative comes around, you get to use a note card again. So this is prime example of when you really want to keep up with your assignments so that you can go ahead and use that note card and put the equations if you need to. Put whatever else you need to up from the rest of the chapter. But you've got to do the work to be able to reap the rewards.
Wait, I have a question.
Yes, Sophie. Go ahead. Yep.
I just didn't know, since it wasn't in vertex form, how many times, like, what is the maximum? Like,
The maximum is your maximum point. So if your parabola opens down, oops, I'm still an eraser. If it opens down like this one did, and I told you to just go ahead and graph this on your graphing calculator until we get more comfortable with graphing, your vertex is going to be your maximum point right there.
yeah, that one, I knew the vertex just because
It's in vertex form. The rest of them, you just graph the equation on your graphing calculator and you just touch at the top and it'll say either minimum or maximum.
you just write that.
Yeah, for now. By the end of the chapter, you'll be able to, even if I give you 2x squared minus 5x minus 12, you'll be able to put that in vertex form so that you can then identify the vertex. Don't look at me that way. You're going to be able to because we're going to start it today. Any other questions? Ben?
Number 1.
Okay, what about it? Well, you still have to get the notes.
Yes, but like, you know, just one example.
You've got to look at the notes because there are 3 different forms. So number 1 is going to be totally different than number 2 and number 4. Because there are 3 different forms, and from each form, you get a different information. So look at the notes. There's videos posted on BB9. If you're still confused, come in and I'll sit down and go through that with you again. Okay? Okay, then let's get out our notes packets. We are continuing on to 2.2. This is going to take us a couple days if you haven't looked at our calendar already. It's going to span across at least a good week, especially with next week only being technically 2.5 days. Nope. You just need to pass 3 math class, 3 credits of math. And if you've passed algebra as a freshman, passed geometry as a sophomore, and passed algebra 2, you're good to go. But if you're looking to go to college, that's not going to cut it.
Yeah.
So that's when you can take like a statistics class. You can go on. There's a pre-college class to get you ready for college. There's pre-calc, things like that. You have a lot of different options. Okay, so we are going to be able to, Sophie, go from one form to the next form. Okay, so we have this nice diagram here for us that allows us to remember what we need to do to go from, for example, if I give you an equation in vertex form, how to go to standard form. If you're going from vertex to standard, this tells me that I have to perform order of operations. If I'm going the opposite way, however, if I'm going from standard form to vertex form, then I have to use completing the square. And we're going to talk and do examples about all of this. Today, we are going to focus on going from standard to factored form. Standard to factored form. So you'll notice example 1 is given to you in standard form, but we want to put it in factored form. So if I take a look here, standard form, okay, it's my phone, sorry, to factored form, what does it say we have to do? It says we have to factor. So here comes that greatest common factor and much more. So I'm going to write down some steps for you guys. And I want you to copy these in on your notes. To factor, here are the steps. First thing you always want to look for is see if there is a greatest common factor, just like we did in our notes. After that, then we're going to use the X box method. That's what I have found is the easiest. You use your equation, you identify your A, B, and C, you put A times C in the top of the X, B in the bottom of the X. So you are trying to fill out two numbers here on the right and the left that multiply to give you that number at the top, but add together to give you the number at the bottom. Two numbers. Is this coming back a little bit? Some people are shaking their heads no. Two numbers that multiply to top number and add to B, or the bottom number. There's only one combination you can have if you do this right. Once you have that, those two numbers, then you can do one of two things. Okay. I personally prefer using the box method then. Or use grouping. And we'll look at both of this, okay? Now for now, these steps probably don't make a lot of sense to you, but we're gonna use them with examples to help you get more comfortable with them again. Does everybody have those steps written down? Okay, let's go ahead and take a look at example 1. F of x is equal to x squared plus 8x plus 15. Is there a greatest common factor between x squared, 8x, and 15? No, 1 is the only thing they really have in common, right? And they don't all have an x, so we don't have to worry about step 1. Step 1, greatest common factor, there isn't one. So now we're on to step 2. Step 2 says to make our box, or our X, excuse me. Step 3 is the box. Remember in standard form, it was f of x equals ax squared plus bx plus c. That's where we get our a, b, and c from. Here's A, here's B, and here's C. So what's my A? A, B, and C are always going to be numbers. So that's going to be a 1. C is what? So for A times C, that's going to be 1 times 15 or 15. B is 8, so that goes at the bottom. So we are looking for what two numbers multiply together to give us 15, but when we add them together, we get 8. Does everyone agree? 5 and 3? Okay. So,
Doesn't matter, like,
nope, you can put 3 on the left, 5 on the right. That does not matter. But A times C does have to go at the top, and 8 does have to go at the bottom. We are now going to take this and go to step 3. Like I said, I'm going to show you both ways. The first way is using a box. And you're going to put all the different parts into a box and then factor out your greatest common factor. You're going to start by putting your ax squared in the upper left-hand box. So 1, you can write 1, you don't have to. So that's x squared. Then I'm going to put my 15 in the lower right-hand part of the box. And then my two numbers that I just found are going to go on the other two parts. And again, here, so it doesn't matter where you put them because it doesn't matter which one's first or anything like that. So 5x though, and 3x. Now, do you see a bunch of different, I see 2 columns and 2 rows. Within each of those, you're going to factor out the greatest common factor. So if I am looking at x squared and 5x, what do those two have in common? They have a 1, but then an x, right? So I'm going to put that at the top. I'm going to do that exact same thing for every row and every column. What do 3x and 15 have in common for the greatest common factor? Not 5, because 3 can't be divided by 5. But they both can be divided by 3, right? Now we're going to look at the rows. What does x squared and 3x have in common? X. And what does 5x and 15 have in common? That's our answer. Our answer becomes x plus 3, which you will notice I got that at the top here. I just put a plus sign by the 3, and x plus 5. And that is it. And this would be f of x, sorry, is equal to. You guys kind of remember that? Hopefully. No. So there are other techniques of figuring this out, okay? This one you don't necessarily need the box method because you have that A, that's 1, but I think it's a good habit to get into because as soon as you have something like 3 when we get to it, you have to use that box method. But here's the other way, and this is either or, okay? Either or. Once you get to the x, you can skip the box completely. If you just rewrite this instead of 8x as 5x plus 3x. So I'm going to write f of x is equal to x squared plus 5x plus 3x. And those came from the x. And then plus 15. So just rewriting it by separating those, that 8x into 2 separate parts. Now we are going to look at each part separately. We're going to look at the first 2 terms and the last 2 terms and pull out the greatest common factor. So what do x squared and 5x here have in common? X. And now we have to put what's left over. What would I need to multiply x by to get x squared? And I would need to multiply x by 5 to get 5x, right? I'm going to do the exact same thing with 3x plus 15. What do they have in common? So I'm going to put a plus 3 because it's a positive 3 they have in common. I would need to multiply 3 by x to get 3x and multiply 3 by 5 to get 15. Notice how they have the exact same parentheses here? That's one set of parentheses. So f of x is equal to x plus 5. It's like you're pulling out the greatest common factor again. And then what's left over, x plus 3 goes in the other parentheses. Do you think that's more difficult? I don't know. I think it's about a horse apiece, to be honest with you. It doesn't matter to me which way you use. Okay, I'm going to do a couple. I'm going to do probably at least 2. I'll do it the second way first, and then number 3, maybe the box method, things like that. You still get the exact same answer. Okay, so I encourage you to, at the beginning at least, try maybe a couple different ways, and then see which one you like after that. Okay, let's try number 2. Is there a greatest common factor? No. They don't all have the same number that can be divided evenly by, and they don't have an x. So that is done. So step 2, I cannot change no matter what I'm doing. You got to use the x. What number goes at the top? Good, because don't forget that imaginary 1. So 100, and then 20 goes at the bottom. What 2 numbers multiply together to get 100, but add together to get 20? 10 and 10. So I'm going to go to step 3 now and do the grouping first. If you think you like the box method, you can try, or try the grouping, and then 3 will do the box method. So I use both, really. I honestly do both. F of x is equal to, I'm going to rewrite the original, x squared, but instead of 20x, I'm going to rewrite it as 10x plus 10x. I'm going to separate it. And then plus 100. Then I'm going to look at each, the first 2 terms and the second 2 terms separately and pull out the greatest common factor. What does x squared and 10x have in common? Okay. And then in parentheses would be in the second set, what do 10x and 100 have in common? And that's a positive, so I'm going to do plus 10. And then that would be so what they have in common, which is x plus 10. And then what's left over goes in your second parentheses. No matter how you do it, though, you will get 2 sets of parentheses right next to each other.
Right?
For this, yes. So what I'm saying, yes, because your coefficient, your a is 1, you can just put those 2 numbers right in your x, right into the parentheses. But I wanted to practice this technique because if you have an a that's different than 1, you can't. So a lot of people just get in that habit of, oh, I'm just going to plop those numbers in the parentheses, and then they get it wrong. Paige?
Do you have to write it even on the both?
Yep. Because remember, x plus 10, and we'll talk about this next week. Oopsies. When you have x plus 10 and then another x plus 10, this is the exact same thing as x plus 10 squared. So you can't just distribute it and say it's x squared plus 100, which a lot of people want to do. So yes, you write both of them, or if you want to use the exponent of 2, you can. Okay. Any questions on that one? Okay, let's take a look at 5. No, 3. Sorry, I skipped 3. Don't know how to count. And 4. So, step 1. Is there a greatest common factor? Nope. And how I determine is I usually look at the smallest coefficient. 7 and 22 cannot be divided by 3, so it's no numbers, and they don't all have a variable. So there is no greatest common factor. So step 2, in the x, what goes at the top? Good. Because you have your A times your C. And then your B goes at the bottom. Any numbers, Zach, that multiply together to get 21 but add together to get 22? There you go. 21 and 1. So sometimes if you can't think of it, it might make sense to write your multiples down for 21. 1 times 21. Can 21 be divided by 2? No. 3 times 7. Can 21 be divided by 4? No. Can 21 be divided by 5? No. Can it be divided by 6? Once you start getting back to the same thing, just opposite, you're done. Those are the only multiples or factors of 21. So, box method. What do I put in the upper left hand? Perfect. What do I put in the bottom right hand? Good. And then the numbers that go on the sides. 21x and x. Or 1x, and yeah, it doesn't matter. And those can be in either spot. Now I got to look at the greatest common factor. So if I look at 3x squared and 21x, what's the greatest common factor? 3 and x, I agree. Greatest common factor between x and 7? Just 1, right? Just 1. It's not even x because 7 doesn't have an x, so it's just 1. 3x squared and x, and 21x and 7. So my final answer would be f of x is equal to 3x plus 1, x plus 7. Piece of cake? Light work. I like it. Okay, try 4 on your own since it's such light work. Give it a shot. Try either method that you want. Just try 4 though. Again, you can work with your partner if you want to, just to make sure that you think you're on the right page. Absolutely. Yep.
Yeah. Yeah, but then it's not negative.
Then you don't have the right combo.
But it is negative because it was
Okay, so you can multiply to the right numbers, but you can add to different numbers. That means you have the wrong combination.
Yeah, it doesn't matter.
Don't disconnect. Okay. Sorry, my computer is frozen right now. I can't do anything. Sorry, just give me a second. I'm trying here.